Welcome to Study Loop.
So in this question, we're told we have two non-interacting spin zero particles, and the energy of the nth eigenstate is n times epsilon. And we also have the degeneracy of the nth eigenstate for each particle is 2n plus 1. So let's say that one of them is in state n and one of them is in state m. Then the combined energy, ENM, is going to be n plus m times epsilon. And the combined degeneracy, GNM, is just going to be the product of the two. 2m plus 1, 2n plus 1. So let's say that their total energy has fixed value, E equals n epsilon. Then the partition function is going to be the sum over possible states of e to the minus beta times the energy of that state. So the possible states are going to be indexed by n and m. But what we know is that if ENM is n plus m epsilon is equal to n epsilon, then we know that m is going to be n minus n. So actually z is going to be the sum over from n equals 0 to n of, sorry, this should have a factor of the degeneracy. Well, no, because we're summing over all possible states, that includes the degeneracy. But if we're summing over n equals 0 to n, then what we're going to have is we need a factor of the degeneracy, gn n minus n, times e to the minus beta times the energy. But the energy is just n epsilon. So that's the same every time. So what we actually have here is e to the minus beta n epsilon times the sum from n equals 0 to big N of this particular degeneracy, which is 2n plus 1 times 2n minus 2 little n plus 1. So let's break this sum down. It's the sum from n equals 0 to big N of minus 4n squared, 4nn, but then we're going to get a minus 2n plus 2n, so that doesn't give us anything. But then we get the plus 2n plus 1. So now we need to use some formulas for sums. So the sum of n squared is going to be, so minus 4 times n plus 1, 2n plus 1, divided by 6. Plus we've got this sum over just normal n, so the 4n, and then we're going to get an n plus 1 over 2. So that's just the sum over little n. And then we've got n plus 1 terms, all giving us a 2n plus 1. So we get a plus n plus 1, 2n plus 1. So we can factor out the n plus 1s from each of these to get that the partition function is n plus 1 e to the minus beta n epsilon. And then we've got a minus 2/3 n 2n plus 1. And we've got a plus 2n squared. And then we've got a plus 2n plus 1. So let's try and simplify this a little bit. So we've got 2 minus 4/3, which is 2/3 n squared. We've got 2n minus 2/3 n, so that's plus 4/3 n. And then we've got just a plus 1. So this is the partition function, the microcanonical partition function in terms of epsilon and n.